The ionic compounds, they form via electrostatic attraction between the ions. So in order for ionic compound to form, first of all, they must be metal, a combination of metal and non-metal. Metal loses electron, non-metal, they gain electron. When metal loses electron, it's going to gain positive charge. And we did look at these examples already. So how do we know aluminum gains 3+ charge? In order to determine the number of charges for the aluminum, you need information based on, let's see if you have the periodic table that gives you the numbers. We need to know the periodic table and the location of the elements in the periodic table. So the question was aluminum, why aluminum has 3+ charge, or what would be the charge or reasonable charge for aluminum? Can anyone help me with that to determine the charge of aluminum? What would be the charge of aluminum, or how do we determine charge of the aluminum? What's step 1?
Find the number of protons, which is 13.
Perfect. So we find the number of protons for aluminum, and that is 13 protons. Perfect. And then?
Find a number of electrons.
Number of electrons, because we are looking at the aluminum that is circled in the periodic table, and that is neutral. If it's neutral, that means since it's neutral, that means number of electron equals number of protons. So I have 13 electrons as well. So for the purpose of charge, we don't have to be worried about number of neutrons. So don't worry about number of neutrons, and the mass is not provided in this periodic table anyway. So if I had the mass of 27 for aluminum, then I could say the number of neutron is the mass minus number of protons. I have 14 neutrons, but since I don't have, I'm only worried about the charges at this point, then I can just look at the electrons and protons, because in order for us, as you said, to determine number of electrons, first we need to know how many protons we have. What is the atomic number of that element in the periodic table? So we know that there are 13 protons because the periodic table tells me, then it's understood that it's same number of electrons. Perfect. What would be next step? I'm trying to determine the charge of aluminum step by step. What would be the next step?
Are we still saying that positive, that the protons are, the aluminum is +3?
I'm saying why is 3. We're trying to find out why aluminum is 3. 3
because
plus charge.
It would have, if it was +3, it'd be because it has 3 more protons than electrons.
Okay, so I'm trying to come up with that number. If I make my question more clear, like we're trying to see how come aluminum has a 3+ charge and not a 4+ charge? What makes the aluminum to be stable with the 3+ charge and no other number? So what is the deal here is the stability of the elements in group 8A or noble gases, right? So every element in periodic table, they want to be like one of those elements in the periodic table. Since it was covered by this label of noble gases, I wrote next to it, neon has 10 protons, argon has 18 protons. That means neon has 10 electrons and argon has 18 electrons. Right? So for aluminum to be stable, number of electrons of aluminum, it has to be like one of these two. okay? Either or. So like neon or like argon. Does it make sense? Now, in order for aluminum to be stable, it must have either 10 electron or 18 electron. Which one is achievable? It's easier. Losing 3 electrons or gaining 5 electrons?
Losing 3.
Losing 3. So whichever is less. So losing 3 electrons or gaining 5 electrons, losing 3 electrons is easier. So this would be the choice. Aluminum wants to be like neon. That's how you decide. Would aluminum be like argon or neon? Then you would say, okay, it's going to be like neon because it makes more sense. Losing 3 electrons is easier than gaining 5 electrons because 3 is less than 5. So aluminum is going to lose 3 electrons, minus 3 electrons. Now, when aluminum loses 3 electrons, the number of protons is not going to change because protons are in the nucleus. Another name for nucleus is do not touch. You don't touch the nucleus of the atom unless it's a nuclear reaction. Electrons, so number of protons stays the same. Number of electrons is going to be decreased to 10 electrons. And as a result, for this ion, or what is left after losing 3 electrons, number of electron and proton is not the same. When you add them up, you would have overall charge of 3 plus, and that 3 plus is going to appear as the superscript on aluminum. So that's how we decide, or we find out that aluminum has 3 plus charge, the charge of the aluminum. Now that we are on this, on this page or slide with the periodic table, going to look at another example for oxygen. How many protons we have for oxygen?
8.
8 protons. Okay. Oxygen has 8 protons. And since it has 8 protons, it is understood that it has also 8 electrons. Okay, 8 protons, 8 electrons, no charge, 0 charge. Now, oxygen wants to be more stable because as it is not stable. It's not like one of the noble gases. What needs to be like one of noble gases is number of electrons. So if we are trying to find out the number of electrons to be same as one of the the number of electrons for oxygen. Now, let me erase the other one for aluminum. So we are looking for oxygen now. Oxygen can be like neon. Okay, that's one choice, to be like neon. The other choice would be like helium. If it wants to be like neon, how many electron must gain to be like neon? 2, right? 2 electrons. And if it wants to be like helium, it must lose 6 electrons. Which one is easier? Gaining 2 electrons or losing 6 electrons?
Gaining 2.
Gaining 2 electrons. So that's why oxygen is going to gain 2 electrons plus 2 electrons. And if it gains 2 electrons, then oxygen is going to have still 8 protons. And now with gaining 2 electrons, it's going to have 10 electrons. And if you add these two, if you add the 2, it's going to give me -2. and that is going to be 2 minus charge. Okay. So you have the 2 minus charge for the oxide. So going back to because we already talked about this, I just wanted to make sure that you take a step back and find out why do we have like aluminum with 3+ charge, the most stable one, or the oxygen with the 2 minus charge. Yes. Question for me?
No, I'm sorry.
That's okay. Well, I tried to turn on the camera, but it looks like this device has 2 cameras. And the back camera, it's on. I need to set up the camera, but let me see. The front camera. It's really okay. That's why it was showing the molecular models in the molecular kit in the back. So anyway, so we are going to go to the slide that we were talking about, the writing the formulas when you have the ions. So we know now why aluminum has 3+ charge and oxygen has 2 minus charge. Bringing together, we have to, a compound is not called compound if it has a charge. So let's say what happens, I'm just elaborating on what we covered last time for now. Let's say I want to write the formula for aluminum oxide, or someone tells me write the formula for aluminum oxide. I say, okay, aluminum and oxide. What is wrong with this? Because aluminum and oxide is like aluminum ion and oxide ion. Aluminum has a 3+ charge and oxygen has a 2 minus charge. If you put these together, a 3+ and 2 minus, 2 minus can only cancel 2+ from the aluminum. And then this is going to result with aluminum oxide with 1 minus charge. So I don't have a compound there. I don't have a compound there yet, because there's a charge. Aluminum oxide is a compound. If it's a compound, is not allowed to have any charges. So what should I do now? Let me get 2 oxygens. So this is wrong, right? So this is wrong. Let me get 2 oxygens because I have to cancel the charges for the aluminum. So I'm going to get 1 aluminum and 2 oxygens. If I get 1 aluminum, 2 oxygens, I have 3+ charge here and a 2 minus, so it would be 3+. Okay, so this is going to give me 3+, and I'm adding that to 2 times -2. It adds up to -1, right? So the other one was a +1, sorry. The first one was a +1. Now if I bring 2 oxygen, is going to be -1. So you have to just continue this too often and then say, okay, I have too many negative charge. Now I have to increase the number of aluminum. So I'm going to do 2 aluminum. So I say Al2 and then O2. So now I have a 3 times 2 positive, and then 2 times 2 negative. So it's a -4 and a +6. This is going to give me Al2O2 with 2+ charge. Then I say, okay, I have 2+ charge. So what should I do now? I have to increase the number of oxygens. So I have to bring 3 oxygens, Al2 and then O3. Now I have a 3 times 2 and then a -2 times 3. Now it's like a +6 -6. Finally, I have the number, correct ratio. So none of these worked. No other ratio worked. So I cannot use these ratios. Okay. This aluminum with 2 is not working. Aluminum 2 oxygen doesn't work. And this is the only one. That's why when I was talking about the shortcut, that you bring a short to do the shortcut. The shortcut is actually to all this. Okay, so you are going to use the subscript as a superscript of the anion as a subscript for cation, and the superscript for cation as the subscript for anion, without bringing the sign. So you just say Al2O3. This is the shortcut to what you had before. And then same thing here. If it's a minus, just a minus, that means it's a -1, because if it's 1, they don't write it. So, and you bring the 1 to calcium and 2 from calcium to bromine. And if it's 1, you don't write it. That was just elaboration on how to write the formula for ionic compound. And then with that, I have to give you an example when you are using more than one polyatomic ion. Let's say you want to write a formula for aluminum with the 3+ charge and a sulfate ion with the 2- charge. Now, this 2- belongs to SO4. It doesn't belong to S, doesn't belong to oxygen. So the 2- is going to go to, the 2 would go to the aluminum. So you're going to cross multiply it, and then the 3 would go to sulfate. So when you are writing, it's going to be Al2. And then when you write the SO4, if you are using more than one SO4, you cannot say SO4 and then 3. What does this mean? It means that you have like a 12 oxygens only, and no, sulfur is 1. So you have to put the polyatomic ion in parentheses if you are using more than one polyatomic ion. If it's just one polyatomic ion, like we had here for carbonate, because sodium is 1, carbonate is 2, so you would switch that. If it's 1, you don't have to, and it would be wrong if you use parentheses here. It would be wrong. You cannot use parentheses for polyatomic ion if the subscript for polyatomic ion is 1. Not for the oxygen, just for the whole package. If it's 1, it's wrong to use the parentheses. But if you are using more than 1, you must use parentheses. It would be wrong if you're not using the parentheses. Okay, and you're going to memorize these, as I said last class. It was just elaboration on how to write the formula. Now to memorize them, just at least this table, okay? And then you have, if the name is given, you want to write the formula. How you're going to write the formula if the name is given. Okay. So name of the ions, you have the, if the formula is given, you write the name. If the name is given, you write the formula. We talked about a binary compound, remember? Binary compound. We talked about the binary compound, and with the binary compound, meaning that we only have 2 types of element. If you have only 2 types of element, the name of the compound should end up with IDE. So the ending is going to be IDE for binary compound. Binary, with the exception, there's only a couple of exceptions. And those exceptions are if you have cyanide, okay, if you have cyanide, which is not in this table, or if you have hydroxide, with exceptions to cyanide and hydroxide. So for the binary compound, it ends up with IDE. So if you see that a compound, name of the compound ends up with IDE, that means it's only made of 2 types of element. Okay, only made of 2 types of element. IDE ending, that means you only have two types of element. There aren't more than that. The exceptions to hydroxide, so you have to remember that if it's hydroxide, is the OH minus, so it's not just the two types of element. This is the exception. So you have to remember the cyanide and hydroxide ends with IDE, but is not binary. You have more than two types of element. Elements with the polyatomic ion that they contain oxygen, they end with ATE or ITE. So you could have AT ending or IT ending for the compounds that they contain polyatomic ion. These compounds, they are known as the higher order. That means you have more than two types of element. Now, if you have the name, how would you write the formula? Well, this formula is given, okay? If you didn't have this formula, what would you start with? Now, you need to know the formula for barium. If you know the symbol for barium, okay, is a Ba. What else do you need to know from barium in order to write the formula? I'm checking the chat just to see if you have the answer in the chat box. Besides the symbol, what else do you need to know in order to write the chemical formula for an ionic compound? Can you hear me? Yes. Looks like it. Any response? What do you need to know for barium before you write the formula? How would you know you have 2 chlorine or 3 chlorine with for each barium? No, for barium, when you have the name and you want to write the formula, you need to know the charge of the barium. Charge of the barium is a 2+. So we are kind of one step higher or closer to not writing like the formula. We already know the charges based on the location of the element in the periodic table. So we know that elements in group 2A, they would always lose 2 electrons to be like noble gas, like the prior one. So we also had this slide here that you were between last week and this week, to, for you to memorize. You have the elements in the group 2A. They have 2 electrons higher than the previous noble gas, so they gain 2+ charge. Basically, they always lose 2 electrons. And then group 1A, they always lose 1 electron. So the charge in the group 1A is always 1+. So if you have an element from 7A to 8A, is just right before the noble gas. So by gaining only 1 electron is going to be satisfied. So elements in group 7A, they would gain the charge of -1. 1A plus 1, 2A plus 2. Okay, 6A -2, because they are 2 electron. They have 2 electrons less than the next noble gas. So you do need to practice writing formulas, like a lot of them, a lot of practices you need, because that's how you, that's basically for writing any chemical reactions, talking about stoichiometry, you have to have the correct formula. So dealing with reactions, so first you have to be able to write the formula in order to name it. And then if you have the name, you should be able to write the chemical formula. So I'm teaching you the steps. So these are like the first steps that you have to take. And I'm walking you through like step by step, how you need to come up with this formula. So the barium, but this is barium chloride is the ionic compound. is made of ions. So first you need to find out what are the ions. The ions for barium, because it's a metal, is a Ba2 plus. What is the chloride ion? What's the formula for chloride ion? The symbol for chloride is Cl, but since it's a chloride, that means that there's a charge to it, and the charge for that is -1. Now you can combine these two and get to the formula. So to combine these two, use the shortcut, bring the 1 to barium and 2 to the Cl and say BaCl2, and that gives you the formula. Okay, I'm going to use another example here. I want you to help me to write the formula for magnesium. Magnesium oxide. What's the symbol for magnesium? A symbol for magnesium is
Mg.
perfect, Mg. What's the charge for magnesium? Magnesium is in group 2A. What's the charge for magnesium? I just said group 2A, they all have the charge of 2 plus, right? Charge for magnesium. So 12 is number of protons, actually, very good, number of protons. But in order to be like a neon, which is the noble gas prior to that, has to lose the 2 electron. But after we learned the basic how they come up with the 2 plus charge or 3 plus charge for aluminum or 2 plus charge for magnesium, now you look at the magnesium and you locate the magnesium in a periodic table, right away you can say what is the charge. Because for any element in group 2A, the charge would be 2 plus. Any element in group 1A, the charge would be 1 plus. I know that you're just like me. I mean, for pandemic, I actually had to get 2 monitors, but you don't have to have 2 monitors, and often you don't have 2 monitors to learn this. So you always need, for chemistry class, you do need a periodic table. Make sure you print one periodic table from either internet or find one of the chapters or from the book. Get a periodic table that shows the number of protons for every element in the periodic table, and then you have the locations. If the groups are not named, like 1A, 2A, 3A, just compare to one of the slides in this chapter and make sure to number them. And then just make up some rules for yourself to memorize. And just like the ones that I'm telling you, like group 1A always would have 1 plus charge, or ions of group 1A is 1 plus. Ions of group 2A is 2 plus. Ions of group 6A is going to be 2 minus, and ions of group 7A would be 1 minus. Okay, so oxygen. Next one is oxygen. The symbol for oxygen is O. And what is the charge for oxygen? Oxygen, since it's in group 6A, the charge for oxygen is going to be 2 minus. Now, we are trying to get the shortcut. Use the shortcut because we don't want to go like too many steps. We do the shortcut, and the shortcut tells us to bring the subscript down to the superscript to the subscripts, the same for the other one, is going to be Mg2O2. The last step that is not covered in here is to simplify it. Okay, make sure to simplify. If it's ionic compound, you simplify it. Please write notes, just like when you come to class. Okay, when you come to class, you bring your notebook and you take notes as even though this is recorded, make sure to take notes. Okay? So for ionic compounds, you simplify, because later on when we talk about molecular compounds, we don't simplify them. We only simplify the ionic compounds. So simplify it. If it's possible, simplify it. So for this one, 2 and 2, we are going to simplify to MgO. Is MgO proper formula for magnesium oxide? Yes, Mg has a 2+ charge and is going to be canceled with the 2- charge from the oxygen. So we have MgO. Okay. The next example that we have here, potassium oxide. Potassium is in group 1A. Okay, potassium is in group 1A. So what the symbol for potassium is K. What's the charge of potassium? What would be the charge for potassium? Potassium is in group 1A, perfect. So that's how you get it. If it's 1A, it's going to be +1. Oxygen is in group 6A, and oxygen is in group 6A. What would be the charge for oxygen in group 6A? -2, perfect. So we have the plus for the +1 for potassium and the -2 for oxygen, because oxygen is in group 6A and potassium is in group 1A. Okay, so because it's in group 1A is a +1, and because is the group 6A is a -2. Now, to bring it together and get the formula, you bring the 2 for the potassium and 1 for oxygen, and you don't write if it's 1, so you would say K2O. The charges must be canceled. Like if you did write KO for potassium oxide, okay, it's wrong. And why is wrong? Because potassium has a 1+ charge and this is a 2- charge. If you bring it together, there would be overall charge of -1, and that's not going to work. So you must make sure that the charges are canceled. Okay. Any questions? Perfect. I see some responses, no questions right now, and let me know if you have any questions. Okay, magnesium hydroxide. So for this one, we're looking for magnesium. Again, Mg. What's the charge for magnesium? You might look at the periodic table or ask me which group you have the magnesium in. Magnesium is in group 2A, so the charge for magnesium is going to be 2+. What's the charge, or what is the symbol for hydroxide? We had a table in previous slide that gave the formula and the charge for polyatomic ions, and you need to memorize it. Hydroxide is always OH with 1- charge. And the combination, I have to bring it's just 1 that goes for magnesium and 2 goes for hydroxide. Hydroxide is considered polyatomic ion because it's not monoatomic ion. So you either have monoatomic or polyatomic. We don't have diatomic ion. Ions are either monoatomic or polyatomic. So if it's a polyatomic ion and you need 2 of them, it has to be in the parentheses. You have to. So basically, if you write MgOH2, this would be wrong. This would be wrong because this 2 only applies to hydrogen and not the oxygen. Hydrogen doesn't have the 1- charge. OH has the 1- charge. So you need the charge from the OH to be doubled. So you would say parenthesis OH2. Next example, potassium. Potassium is in group 1A. What is the charge for potassium? Because it's a group 1A is going to be +1. Nitrate is an ATE ending, so we know that is higher number of oxygen. So for nitrogen, we have either NO2 or NO3. NO2 minus is called nitrite. Okay, NO2 is a nitrite, and then NO3 minus is nitrate. So we have to know then the formula for nitrate. What is nitrate? Nitrate is NO3 with 1 minus charge. And then you're going to bring and cancel the charges. One would be assigned to potassium and one would be assigned to NO3. But if it's NO3, a polyatomic ion, you are using only one polyatomic ion. You cannot use parentheses. So the answer or the formula is going to be KNO3. So that's when you have the name and you want to write the formula. What happens if you have if you have the formula and you want to name it? What would you do? You have the formula. Let's say I'm going to use another formula like barium bromide or magnesium chloride. So I have MgCl2. This MgCl2, how would I name it? First thing I want to see, count the type of, how many different types of atoms I have here. It's just 2, right? Mg and Cl. I have only 2 types of atoms. So this classifies as the binary compound. For the binary ionic compound, write the name for the cation. So you always write the name for the cation. So you would say magnesium. That's the name. Write the root name for the second element or for the anion, which is chlor, and add IDE. So it's made of three parts. Is going to be the name of the cation, root name for the anion, which is chloride. It's going to be chlor, and then IDE, add IDE. All binary compounds, they end up with IDE. Barium chloride, magnesium chloride, potassium oxide, sodium bromide, aluminum fluoride, like aluminum fluoride. That also ends with IDE. Okay. So if you have the formula and you want to name it for binary compound, next one is also binary and it is ionic. How do we know it's ionic? It's coming from metal and non-metal. So these are like very simple, but it's very important for you to first take the one step at a time. It's binary. So we know that is going to end up with IDE. And it's ionic compound because we have a metal and non-metal. Since it's metal, non-metal means I bring the name for the anion, cation first. So that's barium, just name of the cation without bringing the ion. So it's a barium ion, you just say barium. You don't say barium ion, just say barium. And then the root name for chlorine is chlor, IDE. That's how you name it. For the next one, even if you didn't have this here, the root name for the oxygen is just ox, okay? Ox. So potassium oxide. Do I have to worry about that I have 2 potassium and only 1 oxygen when I'm naming ionic compound? No, because it's understood for a chemist, for someone who's studying chemistry 1, it's understood that a compound must be neutral. So if I say potassium oxide, my students in my class is going to laugh at me because they say, this is not a compound. What happened to the ion? You should say ion. If you say potassium oxide ion, maybe, but potassium oxide cannot be KO because this is a 1+ and this is a 2-. You cannot write this. It has to be balanced. If it has to be balanced, you must have 2 potassium, so it's a K2O. This happens only for ionic compound. For ionic compound, you don't have to worry about how many of each you have when you are naming. When you are writing, yes, you have to be worried about. When you're writing formula, you have to be worried about how many of each should I bring to make a compound. Bring as many of each to make sure that your compound doesn't have any charges. But after name, if the name is given to you, then you don't worry about these numbers. They came out right. It must be that way. You must have to have 2 hydroxide for every magnesium. So you don't have to say that is like 2 potassium. Remember, it's 2 potassium for 1 oxide. That was for a student who didn't take chemistry class. So for you, it's good. 2 potassium for every oxygen. That makes potassium oxide. And why is 2 potassium? Because potassium has only 1+ charge. So you have to make the 2 potassium for every oxygen. What about if I had chloride? Do I have to bring 2 potassium? No, you don't have to bring 2 potassium because potassium has 1+ charge and chloride has 1- charge. So potassium chloride is going to be just KCl. It doesn't have to be K2Cl. And if I put K2Cl, it would be wrong. If I put KCl2, it would be wrong because the charges are balanced with 1 potassium, 1 chloride. Okay. Questions for me? Is it helpful? Especially for those of you who did the assignment already? Would it help you to have this information before doing it, or you haven't done the nomenclature assignment yet?
I haven't done it, but I'm pretty sure that this will definitely help me.
Okay, so because I'm going to, a lot of detail because I have the general information. Everything is in the PowerPoint and it's a recorded lecture. And since we are meeting once a week now, I have to make sure that at least, it would benefit in, a more granular level of learning. So you learn a little bit more. It's going to involve more deep learning. So please make sure to watch all the recorded videos that it's already there because it covers more of general stuff. Okay. Oh. Now, if you look at let me go back to that chart to see if it says that we have multiple charges. Yeah, we do have some examples here. You see like iron, you have iron 2+, and then you have iron 3+, cobalt could be 2+ or 3+, copper could be 1+ or 2+. Where do you see this? Chromium could be like 3+ or 6+, but the chromium 3+ is the one that is more stable. For this area of the periodic table, this area of the periodic table has a different name. It's called transition metals or group B. And transition metals and group B, we don't have like general rules. It's not like group A that I say, oh, anything in group A is going to have 1+ charge. Anything in group 2A is going to have 2+ charge. 7A would be 1- and 6A would be 2- charge. And then noble gases, they have no charge because they are stable. They have complete octet or the last energy level, or when you learn about S&P orbitals, it would be S&P orbitals are complete for each level or for the last energy level. So, but when we talk about group B elements, these are different. There are too many exceptions. So for general chemistry 1, you only memorize few. You don't have to, know everything about these transition metals, but make sure that just one thing, some of these transition metals, they have multiple charges. They have variable charges. So we have Fe2 plus and Fe3 plus. If you didn't know this and someone told you to write, formula for iron chloride, you would say, okay, iron and then chloride. Why FeCl2? You would assume that Fe has a 2 plus charge and then chlorine is 1 minus charge. You come up with FeCl2. And then you see there is a formula called written as FeCl3. And if they give you this formula and you try to name it, say iron chloride, how would I name this? Is a binary. I have to write iron and then I have to say root name for the anion and then say IDE. So this would be also iron chloride. Two compound cannot have same name. Since these are two different formula, they are two different compounds, you cannot name them same. Okay, like two brothers cannot have same name. A father and son, if they have same name, they would have like extension, senior and junior, or 1 and 2. Something has to differentiate which one you're talking about, which name you're talking about. Okay? So between FeCl2 and FeCl3, we have to distinguish which one we're talking about. So it's just simple. It's very simple, actually. They say iron, and then because this is coming from iron 2, right? This is coming from iron 2. This is coming from iron 3. How do I know this is coming from iron 3? Because it takes 3 chloride to cancel this charge. It takes 2 chloride to cancel this charge. So this is coming from iron 3. This compound is coming from iron 3. So when I'm naming, I just say iron, and then I say 3, use the Roman numeral, and indicate that this is coming from iron 3. And this one is coming from iron 2. In parentheses, you just write the number. So the reason in that slide we see like Fe2 plus, Fe3 plus is because it's coming back to transition metal and the location of some of these metals in the periodic table. They don't always have the variable charges. Like zinc would always be like 2 plus. You don't have a zinc 2 plus and a 4 plus, but for lead you have 2 plus and 4 plus. For tin you have 2 plus and 4 plus. So some of them only, they have variable charges, and you have to memorize which ones they have variable charges. Now going back to what we had here. Now, if the compound is coming from one of the transition metals with variable charges, you have to indicate the charge of the metal in parentheses using Roman numerals. Okay, now, which ones do you have to be worried about? Which ions or what charges you have to be worried about? I'm going to list it here, the Fe2 plus and Fe3 plus. Copper 1 plus and copper 2 plus. Lead 2 plus and lead 4 plus. Tin and tin 4 plus. I think that's enough actually. For chromium, since it's used often 3 plus and then chromium 6 plus. We don't use the chromium 6 plus often, but at least know that it's a transition metal that has variable charges and is going to, if it's 3, that means that it's, just find out what is the charge of that chromium. in that compound. Okay, so I'm going to give you at least this list for you to memorize. And then if there's anything else, I would indicate you're using, like which chart you're using. Okay, perfect. Now, if we have FeCl2, in order for us to name it, you just have to, it has to ring. The alarm has to ring that, oh, Fe is one of this list that she talked about. Okay, it's one of this list. So I have to now worry about, is this Fe2 plus or is it Fe3 plus? Okay, so how do I know that? It takes 2 chloride to cancel this, so this must be 2 plus. And if it's 2 plus, I'm going to, instead of saying just iron, I have to say iron 2 chloride. And for this one, how would I know that is a 3 plus or 2 plus? It takes 3. So another way, you can basically move this number, the subscript, move it up to make it the charge in order to determine the charge. And no, by this time, you already know that metal would be positive, non-metal would be negative. The first one that is written is positive. The second one is going to be negative. But you are switching back or returning those numbers that originally came from charges, returning back. It works 90% of the time, but there are a couple of times that you have to make sense, use the common sense. Let's say if you have MgO, and you only have 1 and 1 here, Mg and O, they don't have 1 plus charge. So what you need to do in that case, just refer to periodic table. Where is the Mg located? Mg is located in group 2, so it's going to be 2 plus charge, or oxygen is always 2 negative. So oxygen is 2 negative, so Mg must be 2 negative. For MgO, it wasn't applicable. I would probably should have given you better example like FeO. Like in this case, how would you know that is, what's the charge of the Fe? Because if you give the subscript to this, it's going to be 1. Is it 1 plus? Do we have Fe1 plus 2? No. The oxygen is always 2 minus. So since oxygen is always 2 minus, Fe must be 2 plus. And if you had Fe2O3, this one is easy. You just switch the number. So when you are switching, my whole point is when you are switching the numbers, when you are giving back number as a charge, make sure it makes sense. So if you only here switch it back and as you see the 1 and 1, 1 plus and 1 minus, it doesn't make sense. Okay, it's alarming. Oxygen is not a minus 1. Oxygen is a 2 minus, unless is like a peroxide. Like for H2O2, that's like very rare cases, okay? So we don't learn that right now. We learn it when it goes to like oxidation reduction reactions at end last unit 10. By then, you already know about the variable charges of iron and copper and all that. So, chromium, how do we determine the charge for chromium in this case? You do the same, you return the numbers, and then this is going to be 3 plus, this is going to be 2 minus. Does it make sense for sulfur to have a 2 minus? Yes. Sulfur is in group 6A and is going to be 2 minus, so these numbers, they were not simplified. But if you say 1 and 1, it looks like that there was like simplification there. It must have been simplified. But in this case, sulfur has 2 minus charge when you look at the periodic table, so it was not simplified. So you're using the 2 minus and the 3 plus. So chromium is a 3 plus, has a 3 plus charge here. So all we have to say is the chromium 3. And then the root name for the second one, sulf, and IDE. So sulf is the root name, and IDE is indication that this compound is made of only 2 types of atoms, is a binary compound. Questions? Any questions? No questions? Okay. Now, remember I emphasized that if you have ionic compound, you don't worry about the subscripts. But if you have molecular compound, then you have to worry about subscripts. How does molecular compound form? Ionic compound is metal and then non-metal. Molecular compound, just consider this one for now, is a non-metal and non-metal. Okay. So if you have hydrogen is a non-metal, oxygen non-metal, a combination of this doesn't give ionic compound, is molecular compound. Nitrogen is non-metal, hydrogen non-metal, so this compound is a molecular compound. Same thing for carbon, hydrogen, or carbon. So elements that they are on the left side of the periodic table, they are non-metals. So if you have a combination of two or more of any of these blue elements, is going to give you, blue ones are the non-metals, is going to give you a molecular compound. And remember, hydrogen is non-metal, but since it only has one electron, it fits with the group 1A, and that's why we have it in the group as part of group 1. So these are the non-metals, and when they combine, oxygen with nitrogen is going to give you molecular compound. Carbon with oxygen, it would give you molecular compound. So so if you have NO or NO2 or NO3, these are all molecular compounds because it's coming from two nonmetals. CO is a molecular compound. CO2 is a molecular compound. So first you have to decide and identify, is it ionic or is it molecular compound? You have to emphasize on that, is the emphasis on that. And then you would see, is it binary? Is it coming from only two types of elements, or it's coming from more than two elements? If it comes from only two types of element, it's going to end with IDE again. Okay, so you have to give the name for the first element. You give the name for the first element. For this one, is going to be carbon, and then the root name for second element, add IDE. Carbon oxide is a molecular compound. You have to worry about the subscript. So you are going to use prefixes for the subscripts. You see, carbon oxide, you haven't heard of that. Carbon oxide, it doesn't make sense anymore to you because you have to worry about, it's a molecular compound. So you have to say, how many oxygen do you have in that with that carbon? Is it 1 or 2? So if it's 1 oxygen, you would say monoxide. If it's 2 oxygen, you would say dioxide, trioxide, tetraoxide, pentoxide. If the first one is mono, you don't have to say it. If the first one is di, you have to say it. Okay, so carbon monoxide, carbon dioxide, nitrogen monoxide, nitrogen dioxide, nitrogen trioxide, dinitrogen dioxide, and dinitrogen pentoxide. So you're looking at the numbers for molecular compound. And how do we recognize this molecular compound? One more time, if it's a combination of non-metals, then we know is a molecular compound. So I take you back to the examples we have here. For the molecular compounds, we have compounds that they are coming from non-metals, two non-metals. And the elements that they are closer to the metals, or they are on the left side, is going to be written first. So when you have carbon and oxygen, carbon is in group 4, oxygen is in group 6. Carbon is closer to metals, so you write the carbon first when you're writing formula for molecular compounds. If more than one, one compound can be used, you have to use the prefixes to indicate number of each kind of atoms. The last element is going to end with IDE. So let's look at these examples. There are few compounds that they are known, like they have accepted name. Like you don't say dihydrogen oxide. Everyone knows that H2O is water. So you don't have to say dihydrogen oxide. If you say dihydrogen oxide, anybody who has taken chemistry class can write that formula and say, okay, dihydrogen, that means 2 hydrogen, and oxide, that means only 1 oxygen. But water has accepted name and is IUPAC name. So you don't have to emphasize that is dihydrogen oxide. Instead of that, you just say water. So hydrogen is written first because hydrogen is closer to metals compared to iodide. So you say hydrogen, and then iodide, you just say iod, root name for iodine, and then IDE ending. There's 1 nitrogen and 3 fluorine here. So nitrogen, you just say nitrogen. Fluorine, you say the root name for fluorine, that's the fluor, and then IDE ending. Now, let's say they gave me sulfur dioxide. I want to write the formula. The molecular compound is very easy to write formula and also to name it. So if it's sulfur, that's S. And then it says dioxide, that means 2 oxygens. I'm going to write that formula. It's sulfur dioxide. Here it says dinitrogen tetrachloride is a binary compound because it's ending with IDE. It's a binary compound. It's only 2 types of element. It tells me how many of each I have because it's a molecular compound. It says dinitrogen, so it's going to be N2. Tetrachloride, that means 4 chlorine. So this is easy, right? Very easy. So if the first one is only 1, you don't have to say mono. So you just say nitrogen. 2 oxygen, so it's going to be dioxide. If the first one is 2, of course you use the prefix. The second one, even though it's 1, you have to say it, okay? Is dinitrogen monoxide, dinitrogen monoxide. So you would use the prefixes to show how many of each element you have. For the first one, you give the complete name. For the second one, you give the root name plus IDE. Okay. Naming acids. Acids, you could have binary acids or you could have oxyacid. Binary acid, these are hydrogen compounds that when you add them to water, they generate hydrogen ion. So if you name a hydrogen chloride, because it's one of each, this is just a hydrogen chloride. But if they give you HCl, you say hydrogen chloride. But if they give you formula for HCl and then AQ, now we cannot say hydrogen chloride anymore, because the molecular compound has been added to water. And if it has been added to water, now you have to name it as acid. This is an acid now. Okay, so when you name binary, and this acid is a binary acid, you have 2 types. It's either binary or oxyacid. So if it's a binary acid, you have to just say, if it's a binary acid, there's a separate formula. So you would use hydro. For binary acid, you would use hydro. And then you would say the root name for the anion, Like if it's chlorine, it's going to be chloro. I'm sorry, chlor, root name. And then you add ic acid. You see, this is part of the name. Hydro, hydrochloric acid. Okay. Hydrochloric acid, sorry for the spelling. CH is a CHLOR, chlor, like this. Hydrochloric acid. So hydro and ic acid is part of the name for a binary acid. So now, what would be the name for this compound? Can anyone tell me what's the name for this compound? Is a molecular compound, is made of 2 nonmetal. So it's hydrogen. And then the root name for iodine is iod. ID ending, so it's going to be hydrogen iodide. So you have hydrogen iodide, hydrogen iodide. Now, if I change that to AQ, HI, AQ, now I have to name this as acid. Can you help me now name it as acid if you have this hydrogen iodide as the molecular compound name? What should I bring first? Is made only of hydrogen and iodine. In other words, there's no oxygen here. If there is no oxygen in the acid formula, you have to bring the hydro. That indicates that there is no hydrogen here. Okay, there is no, I'm sorry, there is no oxygen. You bring the hydro. There is no oxygen. So in this case, there is no oxygen. So you are going to say hydro. And then root name for the non-metal. So you just say iodo. Iode as the root name. And then ic acid is part of the rule for naming binary compound. Hydroiodic acid. Hydroiodic acid. This is just one word, sorry for the space. Hydroiodic acid, like hydrochloric acid. What would be the name for this acid? HF. Can anyone just try it? HF, acid name. Try it. It doesn't have to be 100% correct. HF, acid. Any response? I have it here. Perfect, perfect. Very good, very good. Hydrofluoric acid. Very good. Yes. Yes, your question.
Professor, do you plan on uploading the PowerPoint to D2L?
If it's not there already, yes. Definitely, yes.
Okay, thank you.
You're welcome. So if the acid has oxygen, like this acid, they have oxygen, there is no hydro. You don't bring hydro. Okay, is understood, is acid. If you say acid, that means there is a hydrogen here. That's the difference between a compound that has acid that has oxygen or no oxygen. That's the indication. If it has no oxygen, you would say hydro. If it has oxygen, you don't say hydro. You just say the root name, nitr, for the non-metal, and then ic acid. As soon as I see there is no hydro, I understand that there is a oxygen here. So nitric acid. So H2SO4, H2CO3, there is oxygen. I don't have to bring hydro, so no hydro. And then the carbon, carbonic acid. So acid needs to be added to the root name of the nonmetal. And then H2SO4, sulfuric acid. You see, I don't have any hydro. If I say hydrosulfuric acid, then it becomes this. That's hydrosulfuric acid. Because there's no oxygen. This is going to be hydrosulfuric acid, but this one is going to be just sulfuric acid. What time is it?